Let's discover how we can evaluate derivatives using our calculator. And so we're going to talk about all the steps required to actually evaluate the value of a derivative given an input value, find what the derivative is at that input value using our calculator. So let's talk about what it means to be differentiable. To be differentiable, a function must be continuous and smooth. Most of the functions that we have studied in calculus are differentiable, but we always need to be on the lookout for when derivatives will fail to exist, because sometimes your calculator will lie to you. This is one function, this absolute value function, that I've used as an example a lot for where a function is continuous but not differentiable everywhere. I can draw this entire function by putting my pencil down on paper and draw the entire function with never lifting my pencil up. That is a continuous function. However, it's not differentiable everywhere. It's clearly not differentiable at its vertex point, and we call that a corner. So there's a function that has a corner. Here's another function that actually has a cusp. For example, x to the 2/3 has a cusp. It is a continuous function, well defined everywhere. Any x value I want to put in this function machine will get me a well-defined output value. However, when I take the derivative of this function, it will fail to exist at x equals 0 because there is a cusp on that function. Functions can also have vertical tangents. The cube root of x has a vertical tangent at x equals 0. When I take the derivative of this function, I cannot evaluate f prime of 0. There is no output there because it's undefined. And finally, here's a piecewise defined function. It is a linear piecewise defined function. For all x values less than 0, it acts like the horizontal line -1. For all x values 0 and greater, it acts like the horizontal line y equals 1. So this is a jump discontinuity, another case where a function is not differentiable, but the single case I've shown you as well where it's not continuous. So don't suspend your math knowledge when you pick up this pacifier that is your calculator. All right, yes, your calculator can find derivatives at a point for you, but you still have to use your math knowledge to determine whether your calculator is telling you the truth or not. So you must be able to calculate derivatives at a given point or a value with and without your calculator. For this lesson, you are going to be using your calculator because I want you to get practice, but be sure to do them by hand when called for on the homework. And remember that half of the test that we're prepping for is a non-calculator active part of the test. So let's do this example. We're going to do it using our calculator. I'm going to walk you through the step-by-step entries that you need to put into your calculator to evaluate this function. So given y equals x cubed, we're asked to find dy dx at the specific value of x equal 2. So the first thing that we're going to do is we're going to put our function, not the derivative function, we're going to put our function itself into y1. So here's a screenshot where I put into y1 x cubed. The next thing that we're going to do is we're going to hit the second, then the mode buttons, and this will take you back to the home screen. And then I want you to choose your math button, and after you choose math, you can either scroll down using your up and down arrow keys, or you can just simply hit the number 8, because the 8th choice on that screen is the nderiv program, which means it's going to find the derivative at a given point of whatever function you enter into it. So once you have chosen the nderiv and you hit 8, or you highlight it and hit the enter button, this is what your home screen should look like. Pause the video if you need to, walk through all these steps and get this into your home screen. The next thing that you're going to hit is the vars button. Vars stands for variables, and I'll show you over here where it is. The vars button is just right underneath, a little to the left of those up, down, left, right toggle buttons. And you're going to hit vars, then you're going to hit the right toggle button once, and you're going to hit enter twice. And that will select the function that you entered into y1. And this is what should be in your home screen now. So what you're telling your calculator is, I want you to find the derivative of the function that I entered into y1. The next thing you'll tell your calculator is you'll enter a comma and then you'll hit the X button, the one that says X, comma, T, comma, theta, comma, N. When you hit that in function mode, it shows up as an X. You're telling your calculator by entering that X after the comma that this is the with respect to variable. And so it's going to differentiate what you have in Y1 with respect to X. Add another comma after that, and then put the X value that you want the derivative evaluated at the very end. So you're going to have in deriv, open parentheses, Y1, comma X, comma 2, because they told us to evaluate the derivative at 2. Make sure to put a parentheses at the end. Then you're going to just simply hit the enter button, and your calculator is going to tell you, hey, the derivative for the function you entered into Y1 at X equal 2 with respect to X is 12. So your calculator can evaluate that for you. X cubed is a polynomial function, fairly straightforward, nothing, to be nervous about as far as is my calculator lying to me or not. For a polynomial function, your calculator is well able to show you what the derivative is at a point. But please remember, the best technology you own is in between your ears. Your math sense to determine if your calculator is being honest with you is impeccable, so trust your math instincts. We know that if f has a derivative at x equal a, we know f is continuous at x equal a. These are the things that we know. Since a function must be continuous to have a derivative, if it actually has a derivative, then it's continuous. But remember, just because a function is continuous does not mean it has to be differentiable everywhere. I just showed you 4 cases where that wasn't the case. Or 3 out of the 4 anyway were continuous, but weren't differentiable everywhere. So it's not a statement that works in both directions, and your calculator may show you a derivative value or a graph a derivative at all points when it shouldn't. So you have a better math sense than your calculator does. So the calculator may return an incorrect value if you evaluated a derivative at a point where the function's not differentiable. For instance, sometimes your calculator, if you entered the function 1 over x and you looked at what the outputs were doing near x equals 0 or at x equals 0, your calculator may tell you it's a negative huge number, when clearly at 0 it's not. At 0 it should give you an error because there is no output there. Sometimes your function may tell you that the output of the absolute value function at 0 is plus or minus 1. So don't blindly trust what your calculator tells you. Now, your calculator will as well graph derivatives without you actually having to analytically find the derivative function and enter it into your calculator. You can tell your calculator what the original function was. For instance, here we want to find the graph of the derivative of x cubed plus 5x squared minus 3x minus 5. But we don't necessarily have to analytically find the derivative of that and then enter it into y1. So we're going to enter this original function into y1. Then we're going to enter in deriv. We're going to hit that vars button and the right button and the enter. And we're going to put in deriv into y2. And using the vars button, put y1 in the open parentheses. So here's a screenshot of what I want you to do. Enter this function into y1, put your cursor down into y2, hit your math button, choose number 8. You don't have to go back to your home screen. That will enter in deriv into y2 with an open parentheses. Then you hit the vars button like we did before and enter y1 in that open parentheses. Next, put the bouncing square cursor on the line to the left of y2 and then press enter. And the line should now be bold. So look at the screenshot here. To the left of y2, do you see that that line, those 4 little diagonal dots there, are much more bold than they are at any other y1, y3, y4. And that means that when we graph the derivative function, it's going to look different. It'll be more bold than the original function. So next, enter a comma, then an x, you're telling it with respect to, then another comma, and another x to tell your calculator what values you want to graph the derivative function of, and then press graph. So this is a screenshot of what I'm asking you to do. Hit comma X, that tells it with respect to, comma X, that tells it what values to graph. Well, you want it to graph all values of X. And so here, when you hit the graph button, is what you should see. You should see that cubic function, the original function up there. And then you should also see the derivative function in bold, the parabolic function. It's going to graph the derivative function for you. So now you have the graph of the original function and the derivative function. Let's say that you just want to see the graph of the derivative function. You don't want to see the graph of the original function. Well, you can hide the graph of a function and just show one or another graph. Put the cursor over the equal sign on Y1 and press enter. Here's a screenshot. You got that black bouncing cursor. Put it over the equal sign and then hit enter. And you should notice that the black box behind the equal sign disappears like it does in this screenshot. This tells your calculator to hide that graph, that you're only interested in graphing the functions that have the black box around the equal sign. So when you press graph this time, all you see is the graph of the derivative function. Your calculator works by algorithms. Some human being sat down and said, how can I write an if-then or if-then-else statement to get this computer or calculator program to do what I want it to do? That's called an algorithm. Well, some are better than others. For the TI-83 and 84, the home screen is more accurate always when evaluating the derivative at a point. Okay, you can do it in the graph screen. I have purposely, for those of you that know how to do it, I have purposefully not shown you how to do that, because depending on the type of function that you're working with, the graph screen, when you evaluate a derivative at a point, may not be accurate to 3 decimal places, but the home screen always will be. So I've purposely shown you how to find the value of a derivative at a point using the home screen only, because your answer will always be accurate to 3 decimal places in the home screen. So for some functions, it's not a guarantee if you use the graph screen to find the derivative at a point. So one video for this lesson. How great could that be? Come next time and we'll do some homework problems involving your calculator and graphing and evaluating derivatives at a point. So come next time ready to do some homework problems.